Mahatma Gandhi Junior College, Pravaranagar. Chapter Electromagnetic Induction, lecture number 2. My name Professor N.B. Sheke. In last lecture, we have studied the two laws, Faraday's laws of electromagnetic induction. First law gives cause, second law gives magnitude. Now, in order to find the direction of induced EMF, scientist Lenz in 1804 to 1864 and Joseph Henry duplicated many of their discoveries and state the law. That law is called Lenz's law. According to this law or rule, the direction of induced current in a circuit is such that the magnetic field produced by the induced current opposes the change in the magnetic flux that induces the current. And this law gives the direction of induced EMF. And that is, induced EMF is same as that of the induced current. And in short, we say that induced EMF tends to set of current, the action of which opposes the changes that causes it or that produces it. And therefore, in this law, this law gives the direction of induced current and induced EMF. In addition with first and second law and along with Lenz's law, these three laws are nothing but laws of electromagnetic induction. Faraday's two laws and Lenz's law, combined the three laws are nothing but laws of electromagnetic induction. Now we consider the applications of Lenz's law. Now the motion of magnet towards the loop. Here, consider the simple experiment, motion of magnet. Consider to study the application, first application. Let us consider a magnet and a loop, that is conducting loop shown in figure. Consider the magnet when moved towards the loop, a current is induced in the loop. The induced current in the loop produces a magnetic dipole, and dipole is oriented in such a way that it opposes the motion of the magnet. Now the north pole of the magnet when pointing towards the loop, then according to the curled right hand rule, magnetic dipole or magnetic field will provide the direction of induced current in the loop. The induced current in the loop will be in clockwise direction in above figure. When magnet is pulled away, current will again induced, or we say that when motion of the magnet north pole towards this loop will suddenly move towards the loop and suddenly move away from the loop. Here, when the magnet is pulled away, a current will again induce in this loop such that loop will have south pole facing the north pole, facing the loop or north pole, and will oppose the retreat current by attracting it, and the induced current in the loop will flow in clockwise direction. Therefore, direction changes when the magnet is pulled away from the coil, away from that loop. This is the first application. In second application, the energy conservation of in Lenz's law. Now we have studied the two cases. Cause of induced current may be, or induced EMF may be caused because of first, motion of conductor or wire in a magnetic field, or when we suddenly move the magnetic induced motion of the conductor, or conductor is suddenly moved in the magnetic field, stationary magnetic field. This is the first cause. Second cause, change in magnetic flux through stationary circuit. When circuit is stationary in two coils experiment, both are stationary, but whenever there is change in the current in the first coil, an EMF is induced in the second coil, galvanometer shows the deflection. Therefore, change in magnetic flux through the stationary coil. These are the causes of induced current. Now, in first case, direction of induced current in the wire such that direction of the thrust or exerted by the conductor by the magnetic field is opposite to the direction of its motion, and thus opposes the motion of the conductor. In second case, current sets up in magnetic field by its own, which within the area bounded by the circuit. Now here two cases. In the second case, opposite to the original magnetic field if the field is increasing, but in second case in the same direction as the original field if the field is decreasing. Now here, change in flux through circuit which opposes the induced current. Therefore, very important statement, that a change in flux through the circuit which opposes the induced current, and therefore this law directly gives or directly from conservation of energy, and therefore induced current flowing through the loop would keep the increasing infinitely, producing joule heating at no extra cost, and thus self-sustaining, that is perceptual motion machine. This law of conservation of energy, and we see that Lenz's law is a necessary consequence of law of conservation of energy, and shortly we result from this discussion, we conclude that every effect of induction acts in opposition to the cause or that produces it. That means induced current is produced, but that opposes the magnetic flux, and therefore this effect of induction acts in opposition to the cause that produces it. This is nothing but, or we say that Lenz's law, energy conservation in Lenz's law. And finally, Lenz's law and Faraday's law. Now, in order to determine the direction of induced current, the polarity of ends of the open circuited conductor can be found easily. Now, to discuss Lenz's law and Faraday's law, relation, how we conclude that Lenz's law and Faraday's law. Now here, as induced EMF is directly proportional to rate of change of magnetic flux. In second law, we have studied that magnitude of induced EMF is directly proportional to rate of change of magnetic flux, and therefore here we introduce the negative sign. The negative sign indicates that change in magnetic flux causes induced EMF, but this induced EMF and current opposes the change in magnetic flux, which produces these two, induced EMF and induced current. Now, in last standard we have studied, if area vector A of the loop perpendicular to the loop, a plane of the loop, and angle theta is 0 to the magnetic flux B, magnetic field B, and also we have studied magnetic induction and area is nothing but magnetic flux, or we say that magnetic flux is nothing but magnetic induction per unit area, and therefore phi is B, vector B into vector A. This is a scalar product, magnetic induction and area. This is the scalar product, that is nothing but phi is nothing but magnetic flux, and therefore substituting this value in this equation, E equal to d by dt of B dot A, vector B dot vector A, and therefore taking magnitude of vector A and vector B, therefore negative sign taking outside, Therefore, RHS towards right, negative quantity, that is magnitude of A and magnitude of B are positive, but here sign is negative. Therefore, vector A is positive, dB by dt is also positive, and therefore as B is increasing with time, therefore by the screw rule, last standard we have studied the screwdriver rule, therefore fixes the positive sense circulation around the loop as the clockwise sense, and thus negative sign in the equation indicates that EMF induced in the coil opposes the rate of change of magnetic flux which produces it, and therefore the induced current in the loop is in clockwise, that is negative sense of induced EMF also is negative, that is the LHS in this above equation left hand side of the equation. Thank you.